So the other usage of nanofibers in drug delivery, controlled drug delivery technologies, and agriculture, as we mentioned, water filtration. Um, so since these fibers are porous, at the same time the pore sizes are very small, you can hold many heavy metals, particularly cadmium and copper, and also you can modify the surface of nanofibers and increase the attraction of these nanofiber surfaces with the defined ions or defined heavy metals, so that this barrier, nanofibrous barrier, will hold it uh, true. Okay, this is important manufacturing technique, and as I mentioned in past 20 years, is one of the leading manufacturing technique in tissue engineering applications, and it has widely application on many sort of tissue engineering applications. So what are the limitations of those fiber bonding technology? You would be ending up with a poor mechanical integrity. If you imagine the higher porous structure, obviously the mechanical integrity is gonna be poor. Residual organic solvent might be causing a toxic effect. So this risk is held in many manufacturing process of tissue engineering scaffold. So you gotta be considering this risk. But as we discussed, having the scaffold material keep in either in laminar hood or in airflow, and make sure that all the organic solvent is removed, you would be processing and using it ultimately in tissue engineering application, and you wouldn't see any toxic effect. But if you directly, without any incubation in laminar hood, directly seed the cells on these organic solvent removed scaffolds, you might be seeing toxic residues. Lack of structural stability, and some techniques can only be used to make very small membranes. This is one of those. Three-dimensional capability is limited. So all the materials cannot be used for all the processes. In this case, you have to have two different polymers with two different melting points. So you have to arrange it. All the materials, difficult to control membrane porosity and morphology. It's hard to control the melting issue, so that would be hard to control the porosity and morphology structure. So the nanofibrous-based material section is over. Next week we're gonna be moving to rapid prototyping and 3D printing and 3D bioprinting subjects. So please watch the links. Also, I send it to you, and try to search online related articles that nanofibrous scaffold materials is being used for tissue engineering applications, and you're gonna see how many of these examples already in trial and already in translated to the clinics. Thanks for listening. Please be safe. Hope you're all in good condition, you and your family. Please obey the rules and stay home. And hopefully this time frame passes smoothly, and we're gonna start our face-to-face lecture soon.